R3 polynomials. So looking at some examples, these first ones, I can get to the right page. Say to just simplify, or well, first is to decide whether each is true or false. And so with 8, we have a squared cubed, and it says that is equal to a to the 5th. Is that true or false? What is it supposed to be instead? Yep, a to the 6th. Okay, so simplifying the expression, we have number 12, 3y to the 4th times negative 6y cubed. So we obviously multiply the numbers first, so that's going to give us negative 18. And then when I'm multiplying, I add the exponents together. So that's going to be y to the 4 plus 3, which is y to the 7. Um, 20. We got negative 4xy cubed times 7x squared y. So any ideas what we get for this one? Or starting with the numbers, what would we get if we multiplied negative 4 and 7? Negative 28. And then I'm going to do the x's, so x times x squared is? Yep, x cubed. And then y cubed times y? Yep, y to the 4th. Let's see, 22. We've got 35 m to the 4th times n, all times negative 2 over 7 m n squared. So if you have one like this, there's a couple things you can do. You can either rewrite this and do like 35 times negative 2 over 7. But if you want, just to save a step, we can act like this is 35 over 1. And so when we're multiplying this times the negative 2 over 7, we can actually cancel out a 7 out of 35, and that gives us 5. So now for the numbers, I would have 5 times negative 2, which would be negative 10. And then m to the 4th times m is going to be m to the 5th. And then n times n squared is n cubed. All right, so this next set of problems still says to simplify each expression. They're just like a power raised to a power now instead. So 26, we've got negative 2x to the 5th, all raised to the 5th. So the power outside is going to everything inside. So looking at the negative, since it's an odd power, we're going to keep the negative. And then 2 to the 5th is 32. And then this is x to the 5th raised to the 5th. So when we have a power raised to a power, we multiply their exponent. So that's going to end up being x to the 25th. Let's see, 28. Negative, and then parentheses 2x to the 0, y to the 4th, and that is cubed. It's a little clearer. Maybe a little better. All right, so we keep the negative outside because that's nothing's happening to it. So then 2 cubed is what? Yep, so we've got negative 8, and then anything raised to the 0 power is what? 1. So basically my x is just going away because this is becoming 1. And then y to the 4th cubed would be what? Yep. Y to the 12th. This next one is going to be a fraction. So we've got number 32. In parentheses, I've got negative 5n to the 4th over r squared, and that whole thing is then cubed. So this still works the exact same way. It just now also has something on the denominator that we're working with. So the negative in there, since it's getting cubed, the negative is going to stay. Then I've got 5 cubed, which is 125. Then I've got n to the 4th raised to the 3rd, so we multiply exponent, so n to the 12th over r squared cubed, so multiply the exponents again, even though it's like on the bottom, and then we have r to the 6th. All right, I'm gonna see if y'all can figure this next one out. So I've got a negative, and then in parentheses, I've got p squared q cubed over r cubed, all raised to the 0. Any ideas on what this one is? Not exactly. What's anything raised to a 0 power? 1. So that's going to be -1 because of the negative out front. If the negative had been inside, it would have just been 1. But since it's outside, that's why it's negative. So we could have still thought about it as like p squared raised to the 0. When you multiply the exponents, that would have been p to the 0. And you would have done that for all the variables. But if you want, because it's on the outside of the whole thing, we can just automatically call that 1. Let's see. All right, the instructions for this next set of problems says to identify each expression as a polynomial or not a polynomial. For each polynomial, give the degree and identify as a monomial, binomial, trinomial, or none of these. So, there should have been, well, maybe not. I guess there wasn't. I was gonna say there should have been rules about how to tell if something is polynomial or not, but I will go over that as we go through them. The degree is going to be the highest powered term on there, and then monomial is going to be if it has like 1 term, binomials 2 terms, trinomials 3 terms, and if it's none of those, then we just say none. So 38 is -4y to the 5th. So one of the things that commonly makes something not polynomial is if there's a negative exponent, if there's a like radical exponent, or if there's a variable in the exponent. Those are kind of like the 3 most common, this is not a polynomial. So in this case, because this one is just -4y to the 5th, this exponent is just like normal. So this one is going to be polynomial. And then when it says the degree, we're looking at the highest powered term. Since there's only 1 term here, we're looking at this to get our degree. So it's degree 5. And this is only 1 term, so this is going to be monomial. Now, if you said that it was not polynomial, none of the other questions are going to get answered, because that only applies when it's polynomial. So with 40, got -9y, whoops, not y, t. Wait, no, it is y. Keep looking at the wrong problem. -9y plus 5y cubed. So based on what I've told you, is this polynomial? Okay. One of you saying no, one of you saying yes. So why? Defend your answer. So we only care about the power when we're deciding if it's polynomial or not. So if it was -9 in the exponent, then it would not be polynomial. But the numbers out front, they don't matter. So this is going to be polynomial because we've got all positive exponents. So then normally we like things written in standard form, which is the highest powered term comes first. But it doesn't say to do that, so you just have to find which one is the highest powered term. And so in this case, what is the highest power that we have on our variable? Yep, so it's going to be degree 3. And we have 2 terms this time, so it's going to be binomial. 46. 2/3 t to the 6th plus 3 over t to the 5th plus 1. What do we think about this one? Yes or no?
Does it have to be a whole number for it to be a polynomial?
Are you talking about the number in front or the exponent?
The number in front.
So we don't really care about the numbers that are in front. So we only care about the exponents on these ones. So this one's a little bit of a trick question, okay? Because I said we can't have negative exponents, and initially it doesn't look like this has a negative exponent, right? But it can't have something like this either. Okay, it can't have like the variable in the denominator. Well, can't have a positive variable in the denominator, like a positive power. Because if you remember anything about rules of exponents, we can rewrite an exponent, we can flip it to the top, or as Mr. Cass used to say, put it where it ain't, make it positive. So you can move it to the top or bottom, but I like to say you can put it where it ain't and change the sign. Okay, because if I move it up to the top so that it is in the right form, I would have 2/3 t to the 6th plus 3 t to the negative 5 plus 1. And so, based on that, I now have a negative exponent, so this is not polynomial. And this right here is why. Any questions about that? Jeez, this section has a lot of problems. Do what? Did you say something? One of you? Okay. I'm hearing things. Let's see. All right, the next one just say to add or subtract as indicated. So basically, we're just adding and subtracting like terms. So we've got 3m cubed minus 3m squared plus 4 plus, and then another parentheses, negative 2m cubed minus m squared plus 6. So with addition problems, it's not as critical that the parentheses are around it. The problem has them to begin with, but if it was a subtraction problem, it is, because that would mean that everything inside that parentheses is being subtracted. So when we get to a subtraction one, I'll show you what I'm talking about. But with this one, basically I could get rid of the parentheses and I could still solve this problem just the same. And so all I'm doing is combining like terms. So 3m cubed minus 2m cubed is m cubed. Then negative 3m squared minus m squared is negative 4m squared. And then 4 plus 6 is 10. So I'm sure you've seen problems like this for quite a while. Probably back since like pre-algebra, you've seen problems like this of combining like terms. But 52 has subtraction. So this problem is also has a number out front. So it's 3 times 8p squared minus 5p minus 5 times 3p squared minus 2p plus 4. So even if this problem didn't have numbers in front of the parentheses that are going to get basically distributed through, I would still distribute this minus sign through everything so that I don't have to sit there and remember that I need to do like 8p squared. I'm modifying the problem. 8p squared minus 3p squared. I just like to go ahead and do it and then get rid of the parentheses altogether and just start combining stuff. So when I distribute this, I'm going to distribute the negative 5 across everything, not just 5. So I'm going to start out with distributing over here. So 3 times 8p squared is 24p squared. 3 times negative 5p is negative 15p. And now I'm going to multiply this negative 5 through these three things. So that's going to be negative 15p squared. Then plus 10p. Then minus 20. And then now I don't have to worry about, saying, oh, I'm subtracting or whatever. I can just take this and combine my like terms. So 24p squared minus 15p squared is 9p squared. Then negative 15p plus 10p is negative 5p. And then just minus 20 over here at the end. So then one that's a little bit harder than that. Negative parentheses 8x cubed plus x minus 3 plus 2x cubed plus x squared, and then minus parentheses 4x squared plus 3x minus 1. So I'm going to go ahead and these negatives that are outside the parentheses, I'm going to multiply them through just to help me to not forget about them, because usually with these, the only problem really for people is the signs. So it's going to become negative 8x cubed minus x plus 3. Then over here with this just being added, I can get rid of the parentheses and just basically rewrite them down to plus 2x cubed plus x squared. Then minus 4x squared minus 3x plus 1. So then a lot of times when there's a lot of things going on in the problem, I will underline based on the power that's on things. So I have negative 8x cubed plus 2x cubed, so that's going to be negative 6x cubed. Then x squared, I've got x squared minus 4x squared, so that's negative 3x squared. Then my x's, I have negative x minus 3x, that's minus 4x. And then I'm left with just my constants, which is 3 plus 1. So that's going to be plus 4. You okay with those? Okay. So now we're going to be foiling, or sometimes super foiling, as I like to call it, when there's like bigger things that are getting multiplied. So starting with 56, I have 5m minus 6 times 3m plus 4. So I FOIL, so first term is going to be 5m times 3m, which is going to be 15m squared. Then I do 5m times 4, so that's the outside term, so that's going to be plus 20m. Then I do the inside terms, so that's negative 6 times 3m, so negative 18m. Then the last term's negative 6 times 4 is minus 24. And then I combine this middle term to be 15m squared plus 2m minus 24. Now we're going to have one that I like to call superfoiling just because it has 3 terms in each parentheses. So I've got r minus 3s plus t times 2r minus s plus t. So I work my way across. So I do the first term times everything in this parentheses, then I do the second term times everything in this parentheses, then I do the last term times everything in this parentheses, and then I go through and I combine like terms. You do have to be really careful with this problem because it has 3 different variables, so we have to make sure the variables match up when we're combining like terms. They have to, like anything that has multiple variables, they have to like both be present to be able to add them together. And I will always write my variables alphabetical order when I'm like multiplying. So, I've got r times 2r, so that's going to be 2r squared. R times negative s is negative rs. R times t is rt. So that took care of r. So now negative 3s times everything. So negative 3s times 2r is negative 6rs. Negative 3s times negative s is going to be positive 3s squared. Negative 3s times t is negative 3st. So now I'm done with the negative 3st, so I just have to do the t. So that's going to be plus 2rt minus st plus t squared. So I know that there's no other squared terms other than just when the variable itself has been squared. So I'm going to go ahead and write all of those down. And as I go, I usually cross stuff off so I make sure that I've accounted for everything. So I'm going to have 2r squared, cross that one off, plus 3s squared, cross that one off, and then plus t squared. I'll cross that one off. Then, as much as possible, I like to stay alphabetical order, but when it's kind of a lot of different letters, it's a little bit more difficult to do that. So I'm going to start with this rs here, negative rs, I mean. I'm looking to see if any other terms have just an r and an s, and I see that negative 6rs does, so that's going to be minus 7rs. I'm going to cross that one off. Now I'm going to look at the RTs. So I've got RT and then plus 2RT. So that's going to be plus 3RT. And then lastly, I have minus 3ST minus ST. So that's going to be minus 4ST. Any questions about that one? I know it's kind of a lot when it's basically variables.
Still doing stuff?
You can hang if you're going to be quiet. We're almost done.
Can I hang? Can I study?
We're almost done. I have 3 more problems, I think. All right. These ones still say find each product. These ones are special types, though. So 72, we've got 2m cubed plus n times 2m cubed minus n. Do y'all happen to know what this special type was? Or is? It still is, not was. I think when Joey was in my class, this was like his favorite one.
Oh, this was the easiest thing for me. Wait, this is
This one. Do you remember what it is? What the name for it is?
I remember I used to.
You used to scream it out all the time.
Quadratic formula?
No.
I used to do that one pretty well.
It is a difference of squares.
Oh, yeah.
So, all we do is we take the first terms and we square them, and then it's minus the last term squared for a difference of squares. And it is that because this is a plus and this is a minus, and it's the same thing repeated otherwise. So this becomes 4m to the 6th minus, or wait a second, I lied. It's, yeah, to the 6th. Yeah. And then minus n squared. So if you say didn't recognize it was a special type, or you don't know how to like write the special types, we could have still FOILed just like normal. And all that's happening is that middle term is getting canceled out, which is why we don't have one, because of the plus and the minus. So,
What class is this?
college algebra.
College.
Let's see, 74 is a minus 6b, and that whole thing is squared. So this one is another special type. It is a perfect square trinomial, and so I think in the notes it should have showed you what that was. So the last thing that you should have had in your notes was the perfect square trinomial. So when you have x plus or minus y or whatever, those can be anything. So in our case, it's going to be a and something b squared. We have the first term squared, and then it's plus or minus, so it's the same sign as whatever's in the middle. 2 times the first term times the last term, and then plus the last term squared. So if you know the special type, you can do it that way. If not, you can also do it by hand. So this, you can think of it, if you need to FOIL it, as a minus 6b times a minus 6b. And then you could FOIL it, and you'll get the same answer either way. But this special type would give us that it's a squared minus 2 times a times 6b. So that would be minus 12ab. And then the last one is always positive, so it's going to be plus 36b squared. But you can always FOIL, and you'll get the same thing if you don't know the special types. And the very last problem that we're going to do, 96, negative z cubed times 9 minus z plus 4z times 2 plus 3z. So we're going to distribute first, then combine like terms. So this is going to be negative 9z cubed plus z to the 4th plus 8z plus 12z squared. And we need to write our powers in descending order. So I'm going to rewrite this as z to the 4th minus 9z cubed plus plus 12z squared plus 8z. Any questions about those? Nope. All right, so I'm going to put your problems up for you. I am not going to make them due on Monday because you don't really have a ton of time to do them. So I'm going to give you class time on Monday to do them. And then I think I may have had up there a quiz on Tuesday. It'll probably be Wednesday instead. I can't tell what date it says, but 13, 19, 27, 29, 43, 53, 59, 67, 69, 77, and 91. Actually, hold on one second. Hold on. Scratch 77. I'm going to change it to 73. There we go.